Greetings guys, this is Magnan Masmai's lectures online. We continue with mathematics N5 and today we look into integration, the application of definite integrals. Here we are given a question which says given x equals to y over 6 and y equals to 3x squared. And then the first question says calculate the coordinates of the points of intersection. The second one says draw a neat graph to show the enclosed area, the representative strip, and the point of intersection. The third one says calculate the magnitude of the area mentioned in question 2. And then the last one says calculate the volume of the solid of revolution formed when the area in question 2 is rotated about the x-axis. So let's answer the first one. To calculate the point of intersection while given this, you have to make the same variable subject of the formula in both equations. So this side it says x equals to, so let's make it to be y equals to. And for us to do that, we'll multiply both sides by 6. And this 6 will cancel this 6. So we have y equals to 6x and y equals to 3x squared. Therefore, let's call this y1 and this y2. Point of intersection is where the two graphs intersect one another, meaning that their y value is the same. So y1 and y2, they're equal at the point of intersection. And then 6x is equals to 3x squared, and 0 equals to 3x squared minus 6x. 3x equals to x minus 2. Therefore, x equals to 0 and x equals to 2. And then our y values, here the y value is 0, and then here the y value is going to be 6 times 2. So the y value is 12 in this case. And then the second question says draw a neat graph to show the enclosed area, the representative strip, and the point of intersection. So in this case, we have to draw the graph. We'll start with the parabola. There's the y-axis, there's the x-axis. So the parabola is like this. Y equals 3x squared. And then the straight line. The straight line is going to be something like this. Actually, there's not proper. Erase a bit. The straight line is something like this. Yeah. Then y equals to 6x. Then the representative strip, let's make it blue or red actually, green. There's the representative strip, which is dx in this case. And then the point of intersection, let's make it red. It's 2 and 12. And the other point of intersection is 0 and 0. That's it for this question. And then the area they are talking about, when they say the area, it's this area, like inside between these two graphs. There's the area. You can just shade it with a different color. There's the the area. Sorry about that. And then the third question says calculate the magnitude of the area mentioned. To calculate the magnitude of the area mentioned, you say area equals to the integral from A to B of top minus bottom. What this means is that is the integral from A to B. A to B is the limits, whereby the limits are going to be the point of intersection, which is the bottom point intersection to the upper point of intersection. And then top minus bottom means the top function minus the bottom function. So let's write the actual thing and see what we get. So our area is going to be our top function, which is 6x, minus our bottom function, which is 3x squared, and this is in terms of x dx. And then our lower limit for x is 0, when our upper limit for x is sorry about that. Our upper limit is 2. So we integrate in terms of x and have the following what you call lower and upper limits. So let's integrate and see what we get for this area. So if we integrate, we get 3x squared minus x cubed from 0 to 2. This becomes 2 squared minus 2 cubed minus 3 0 squared minus 0 cubed. This gives us 3 times 4 minus 8 minus 0. There's 12 minus 8. It gives us 4 units squared. And that's it for the third question. And then for the fourth question, which says calculate the volume of the solid of revolution formed when the area in question 2 is rotated about the x-axis. For this, we've got a formula in our formula sheet, which is in page, let me check, it's page it's the last page of the formula sheet. In the last page of the formula sheet, we've got section written volumes. So use that volume, and we're going to use the first one, which says Vx. If it's not written Vx, then it has to have dx in the integral. We're going to use that formula. That formula says V equals to pi a to b y1 squared minus y2 squared dx. So in this case, it's going to be pi. Our a and b is the same as the previous question. It's going to be 0 to 2. Then our y1 and y2 is the same as in the previous question. So it's going to be 6x minus 3 x squared dx, and this is squared, this is also squared. So we're going to have pi 0 to 2 of 36 x squared minus 9 x to the power 4 dx. And then from here what we do is to integrate, and if we integrate this, we're going to have pi x cubed, then we've got 36 divided by 3. 36 divided by 3 is 12 here, minus 9 over 5 x to the power 5, 12 2 squared minus 9 over 5, 2 cubed, 9 over 5, 2 to the power 5, minus, we know that if we plug in 0 we're going to get 0. If we punch this into the calculator, get pi 12 2 cubed minus 9 over 5, 2 to the power 5. This gives us let me see, gives us 120.637 units cubed. And that's it for this question. Thanks for watching Magnanimous Minds Lectures Online. Please do subscribe to our channel as well as liking our videos. Also do follow us on our social media platforms: Facebook Magnanimous Minds, Instagram Magnanimous Minds, Twitter